there, let's take a look at this problem, largest rectangle in histogram from Interviewbit. So in this problem we are given an array of integers and we have to draw a histogram out of those integers where each integer represents the height of a bar in that histogram. So we have to find the maximum area that can be formed out of that histogram. Now before we jump into the solution, please do subscribe to this channel because we post a lot of similar content in which you might be interested. Let's consider the example that is given in the question. So we are given the heights of the bar which are represented in this histogram. So in order to solve this problem, we'll take the height of each bar and try to maximize the rectangular area that we can get out of that height. So if we take the height of the rectangle equal to 1 for this little bar, then the maximum area for height 1 will be represented by this rectangle, which will be equal to 6. And if we consider the height of this bar, then the maximum rectangular area will be represented by this rectangle. To solve this problem, I have written down some steps that we can follow to easily reach to our solution. So first of all, we'll take an integer maximum area and initialize it to 0. This will represent the maximum area of the rectangle that we can get out of the given histogram. Secondly, we'll take our stack and then we'll traverse through the given integer array, and for each integer we'll either push the current index to the stack if the stack is empty, or if the top of the stack represent an element which is lesser than the current element, or if the element at the top is greater, then we'll pop out that element, and before popping it out we'll find out the maximum area that is possible for that given height. And after the traversal is complete, we'll get a sorted array in our stack, and then finally we'll pop out each element one by one and try to figure out the maximum area that is possible with each given height. Now in order to understand how to calculate the maximum area from a given height, let's consider this example. So let's consider that we are at this position, the last position, and now we can clearly see that the earlier positions are greater than this, the earlier heights are greater than the given height, so we need to pop out all these elements from our given stack. So let's consider that we are at this height. Now in order to calculate the maximum area, we need to calculate two things, that is the left part and the right part of our length. We already know the height, we need to calculate the left part, which is this one, and the right part, which is this one. The right part is easy because we currently know that we are at this index and we need to pop out this element. So we just need to take this difference and we are good to go with the right part. For the left part, we need to pop this out and then calculate what is left in the stack. So after popping this out, we'll clearly see that this is the height that remains, and we can clearly find out this portion as well. Now let's try to code out the solution. So first of all, we'll take a stack and an integer maximum area and initialize it to 0, stack of integers, and then we'll traverse through the array and then before pushing any element we'll need to pop out all the elements which are greater. So while s dot size and a of s dot top is greater than ai, remember that we are pushing the indexes and not the elements, because we need to find out the difference in index as well. So while this is true, we need to calculate the area, maximum area, that is represented by the given topmost element of stack. So height of our rectangle will be a of s dot top and then the left part will be equal to first of all let's take the topmost element in another variable. So int top is equal to s dot top and then let's pop it out as well. So s dot pop, so height becomes a of s dot top, which is top, and left part is initialized to top plus 1. We are doing this because we are considering that after popping out this element there are no elements left. However, if there are still elements left, we need to update left part. So if s dot size left will be equal to top minus s dot top and then int right will be equal to I minus top. And then the local area or the maximum area which is represented by this height will be height into left plus right minus 1. Minus 1 because we have considered the current bar twice. So we also need to update the maximum area. Maximum area will be equal to max of maximum area and local area. And then after we have popped out all the greater elements, we push the current element. So s dot push the current element, which is I, which is the index and not the element itself. And then after we have done that, we'll pop out all the elements which are sorted in the stack. So while s dot size we take out the height, which is equal to a of top, and top is equal to s dot top and s dot pop, we pop out the element, and then int left becomes top plus 1 again, and if there are elements left we need to update this left part. So if s dot size left becomes top minus s dot top. And now for the right part, it will be equal to a dot size minus top. The right side, consider that we are at the current height and all the elements towards the right are greater than this element. So that's why we have taken the right part equal to a dot size. And then similarly we need to find out the local area and the maximum area for this as well. And now let's try to submit it. And it has been accepted. If there are any doubts, you please do mention in the comments. Thanks for watching.